Welcome to UNITA's course on PCB sampling and screening. This chapter will describe the procedures to detect PCB in dielectric oils from transformers and capacitors through sampling and screening. Sampling. Sampling is an investigation tool to where a portion that is representative of the oil is collected and analyzed. In our case, we want to know PCB concentration in the oils to identify contaminated equipment, as well as to confirm our preliminary results from previous inventories. Usually around 50 milliliters are sampled. Oil samples should be taken under positive pressure through the sampling valve of the transformer, which should be previously flushed. Personnel in charge of sampling must have the technical knowledge, qualified to extract samples, and be familiar with related safety measures. The sampling team consists of a stakeholder representative and of personnel from both the environmental and technical departments. The stakeholder representative should be the professional of the public service company, for example, the National Electrical Facility. Since sampling transformers can be dangerous, it is necessary to follow health and safety procedures throughout sampling. Therefore, the stakeholder representative should be an experienced engineer responsible for the equipment and be authorized to enter a transformation substation, disconnect the equipment, or work with live transformers, if necessary, and verify compliance with the safety procedure during sampling. The team member from the environmental department is responsible for supervision and to ensure that all procedures follow environmental sound practices. The technical personnel. 2 electrician technicians will be responsible for the collection of samples. Both of them must be qualified to handle transformers when they are disconnected or connected to high voltages. One of them will be manipulating the valve. Meanwhile, the other technician holds a sampling bottle under valve to collect 50 milliliters of the oil. Then completion of sampling forms, correct labeling of the samples, and detailed records of technical information of the transformer are essential for successful sampling. Sampling material. To collect the samples, the following materials are needed: 50 milliliter glass bottles, bubble wrap and boxes for safe transport of the samples, a tray to prevent spills, absorbent tissue to swipe oil drops, labels for samples, tools and syringes with plastic tubes in case the oil has to be sampled from the top of the transformer. In case of small and large spills, spill kits for cleaning up are needed. The team will need good equipment to carry out sampling in the quickest and safest conditions. Ford Transporter pickup is the most versatile vehicle, offering enough space for all the materials and equipment. To reach some of the transformers, the technicians will use a fiberglass ladder. For moving or adjusting live electrical equipment, the technicians will use an insulated, dielectric tested fiberglass tool, usually called a hot stick, to protect themselves on site. During sampling, the following personal protective equipment are essential: head protection, eye protection, high visibility clothes, protective overalls, rubber gloves with protectors, and nitrile gloves for each sample, a harness when working 6 feet or more above the ground, and dielectric foot protection. The sampling procedure for transformers. Before the sampling starts, the sampling procedure, safety, and emergency measures are to be reviewed during a preliminary meeting. All measures must be discussed within the team, and responsibilities assigned and clearly understood by team members. Prior to sampling, the manufacturer plates should be located on each transformer, and the information together with information on the location of the equipment are to be filled in the inventory form. If the manufacturer plate is missing or not legible, the team should collect other information that can be used to identify the transformer, or assign it a unique number, in order to identify the equipment during the inventory. Once the transformer has been made safe for sampling, identify the drain valve, located usually at the bottom of the transformer. One technician places a tray beneath the valve in case of spills or leaks, and opens very slowly the drain valve. Here it is important that the technician has both hands free to do this, while the other technician holds the sample bottle directly beneath the drain valve to collect 50 milliliters of oil. Now the drain valve and sample bottles are closed. Immediately swipe clean with absorbent pads. As some transformers might be located above ground, then a fiberglass ladder and harness will be needed to reach the drain valve. For this scenario, and when we do not have a platform to place the spill tray, it will be important to have a piece of wood or plastic at hand to place it under the drain valve in order to be able to place the spill tray and the sample bottle on it. In case the drain valve at the bottom of the transformer cannot be used, the sample should be taken from the filling cap at the top of the transformer. This will require additional safety precautions. The transformer will need to be offline and disconnected from the network to collect the sample. In order to collect the oil, a rubber tube and a syringe are needed to take up the oil. Once about 50 milliliters are taken up by the syringe, carefully dispense it into a sample bottle. A new syringe and tube should be used for each sample taken this way. The glass bottle containing the sample must be labeled immediately during sampling. The label should include a unique sample ID that allows the sample to be matched to equipment from which it was taken. The information plate on the transformer may also be renewed, for example, with resistant plastic labels. During sampling, the sampling team must wear personal protection equipment and have materials and tools at hand to be prepared to contain or mitigate any small spills or leaks that may occur, such as personal protection equipment, absorbent tissue to wipe everything clean, tools and keys to remove valve stoppers, spill trays to place beneath the valves to contain leaks, tape and plastic bags to collect contaminated wastes that may be generated as a result of the procedure. It is recommended that the facilities have an oil spill containment kit of a larger capacity, as spills may occur when loosening the valve or due to a deteriorated welding. All sampling material, such as trays and tools, must be cleaned with organic solvents to be used again. If connected transformer with high voltage have to be sampled, the technician must know and follow security procedures established by the sampling team. For example, they need to comply with a safe distance. Be sure to follow the correct procedure. For more information, have a look at our tutorial on PCB safety and security on our PCB platform. Capacitors have no drain valve or other opening, therefore must PCB be identified with the information found on the manufacturer plate of the capacitor. Additional information might be found from lists of manufacturers. In general, literature suggests that if a capacitor was manufactured before 1983, or if it does not have an information plate, we should assume it contains PCB and dispose it as such. Some capacitors have a label or plate indicating non-flammable liquid or non-flammable synthetic oil. This would indicate the presence of PCB and need to be tested. If no information can be found on the type of oil, brand, or manufacturer, then a sample should be taken by drilling a hole into the equipment. In this situation, the capacitor can no longer be used and must be disposed of properly. After sampling, the samples are ready for PCB screening. Each sample collected should be screened on site or another designated place. Two screening methods are commonly used: PCB detection with electrochemical readings such as the L2000 DXT analyzer, and rapid PCB screening tests such as the Clor-N-Oil test kits. Both methods do not measure PCB content directly, but provide a quantitative analysis of the chlorine content in an oil sample. They have sample preparation steps in which organic chlorine, here the PCB, are converted to chloride using a metallic sodium reagent. The analysis time for each sample is about 10 minutes for both methods. In most cases, they are a reliable indicator of the presence of PCB, but may also give false positive results when the oil has become contaminated with other chlorine-bearing substances. The L2000 DXT is a portable analyzer system for on-site analysis of PCB suitable for 4 matrices: transformer oil, water, soil, and surface wipe samples. The chloride is detected and quantified using a chloride ion-specific electrode. The analyzer then mathematically converts the chloride reading to the equivalent concentration of PCB. Conversion programs are available. The Clor-N-Oil test kit is a disposable all-inclusive test kit specifically developed for the determination of PCB in transformer oils. For the PCB inventory, the test kit with the action level of 50 parts per million should be chosen. The test kit is calibrated on Clor 1242, the Clor with the least amount of chlorine, 42% by weight, to obtain the most conservative results. The PCB level is determined by a color test. When the sample in the test turns blue or purple, you can be assured your oil sample is below the action level of 50 parts per million. When the color is yellow or colorless, it is above. Samples that have concentrations equal or higher than 50 parts per million of PCB are labeled positive from the screening. These samples should be sent for further testing to a laboratory for gas chromatography analysis to determine exact concentration for single PCB congener or mixtures of congeners, so-called aerochlors, to determine the level of PCB contamination in these samples and to confirm the screening results. An e-learning course about laboratory analysis of PCB with gas chromatography can be found on our PCB platform. The results from the screening and the laboratory analysis need then be added to the PCB inventory database. This information will be necessary to decide the PCB elimination procedure. Now we wish you good luck with PCB sampling and screening.